Good morning, honors geometry. Hope everybody's doing okay. We're going to be talking about data analysis, primarily central tendency and measures of spread today. Central tendency will take you back to elementary and junior high, talking about median, mode, mean, and then range is actually probably the central or the spread that you learned back at that point in time. We're going to learn a new way to measure spread, standard deviation, which luckily you won't have to calculate, but we'll talk about what it means. Once again, these measures of center of data, set of data, are going to seem familiar to you. The mean is just the sum of all the data points divided by how many there are, right? So we're going to add them up, and we're going to divide by the number of items. The median is where we put the data in order, and then we determine which element is the middle of the elements. If there's an odd number, there will be an exactly one middle number. If there's an even number, there will be two middle numbers. We're going to have to divide those by 2 to determine the median. And then finally, the mode, which is just the most often occurring data element. There can be multiple modes. So you can see if there's 2 modes, we would call it bimodal. Or there could be multiple modes. There could also be no mode at all if everything occurs exactly one time, or if everything occurs exactly 3 times, and we just say, well, there's no mode to this set of data. One thing about that, you've got to look out for outliers. Outliers are numbers that are way, way too big or way, way too small compared to the rest of the elements. And I used to have a good activity I would do to talk about really how outliers can affect your measures of center. And we would, as a class, each pick an occupation. And this is kind of an older activity. Some of these sellers may be a little lower, but most people would end up making somewhere between $50,000 to $80,000, depending on their chosen career. We would then go buy a house, and we would buy a house on the street. And the problem is that Tiger Woods also lived on the street. At the time, he was the world's most highly paid athlete, making around $47 million a year. And so when we ran our calculations, what we would find is that the average salary on the street, the mean, was $3 million-ish, depending. And the median was more in the mid-$60,000 range. And we would talk about which one of these was really more representative of the average person on the street. And it was just a good illustration on how outliers can really throw off the measurement of the center of the set of data. But anyway, moving on. Measures of spread. So as I mentioned, you definitely learned about range in previous years, which is just the difference between the smallest element and the largest element of your data. Pretty straightforward, and I'm sure you've been doing that for a long time. But the standard deviation, we'll get into a little bit more today, and that is a much more useful measure of the spread of data. I always look at standard deviation when I average your test scores just to see if it was a kind of compact test where a lot of people scored similarly, or if it was really spread out with a lot of highs and a lot of lows. The standard deviation is a good way of measuring normal distributions and what percentage of data points will fall within a certain range. And we'll definitely see a couple of problems where we use the standard deviation. Good news is you won't have to calculate it, because as you can see, it's a slightly more complicated calculation. But we'll talk about what it means, and we'll talk about how to use it. Even in like AP stats, they don't calculate their own standard deviations. We generally let the calculators do that for us. Here's a little illustration. We have the dogs, and we find the mean height, the average height of these dogs. And that just tells us roughly that green line there. Well, what is a dog's average height? You can see only one of them really is exactly average. Most of them, let's see here, this guy's barely above average. Most of them are either below or above. On the other hand, when we look at the standard deviation, we're not talking about what the center, there's that green line still, but now we're talking about how far away from that center are we? And you can see this blue line right here and this blue line right here. And that's one standard deviation away. It looks like they calculated it to be 147 probably millimeters here. And you can see that most of the dogs fall within one standard deviation. At least 3 of them did. We have one little short dude and one tall guy that were above that. And that's when we know that the data is starting to get away from the center. We'll be talking about that concept today. So let's start in with some definitions and notes. A lot of this should be review for you, so hopefully not a big deal. The mean, once as we said, is just also known as the average, and it's the sum of all the data points divided by how many of them there are. We call it X bar, that's how you read this. So if you see an X with a little bar above it, that means it's the mean. And here's an example for you. You can pause these videos anytime to take a closer look at them, but we added these 5 numbers together, divided by 5, and found the average was 82. Quite often, most often, we're not going to get exact integer values for our averages. Usually they're decimals, but I'm sure that you remember that. This is more of a typical SAT or PSAT type question. They're not just going to give you a list of like 5 or 6 numbers. They're going to give you a table. And this is where you have to be careful, because a very common mistake is that people are going to take these 4 scores, they're just going to add them together and divide by 4. But there aren't 4 tests, because there were 5 70s and 7 80s and 9 82s and 8 90s. So really 5 plus 7 plus 9 plus 8 looks like about 29. There are about 29 tests. So we have to be careful that we read the tables correctly. I would need to multiply the 70 by 5 and the 80 by 7 and the 82 by 9 and the 90 by 8 to get the sum. Then I can take that sum and divide by the total number of tests, 29. So actually we should be getting about an 81.7 on this. It says at the bottom, the mean is the best measure of center if it is a roughly symmetric distribution. And in these normal distributions, we'll always find the mean exactly in the middle. By the way, here's yet another way to symbolize the mean other than X bar. X bar I think you'll see more often, but this symbol right here, mu, is another symbol that will be used in statistics courses and textbooks and such to symbolize the mean. Let's move on. The median is the middle value in a set of data. And so if we have an odd number of data points, 1, 2, 3, 4, 5, right, we're going to get exactly 1 middle. That's pretty easy. Hardest part is just ordering them, putting them in order sometimes. You have to do that. Now this guy right here, 1, 2, 3, 4, 5, 6, we have 2 middles. So we're going to have to average those middles to get the median. And I'm sure you've seen this one before. Now, if you have outliers in these 2 cases on the middle and the right graph, we can see that the mean has been pulled to one side or the other because there are more data points above or below the middle. And you know, outliers will cause that, like in the Tiger Woods example. And that's when it's probably not a bad idea to maybe use the median instead of the mean to think about the center measurement of your data. And then finally, the mode, as we discussed earlier, is just the most frequently occurring measure of central tendency. And what it happens the most, the first set of numbers, we have 3 4s, so 4 is the mode. In the second example, we have 2 5s and 2 7s, so 5 and 7 are both modes. And then finally, the last set of data, all the numbers occurred the same number of times, 2 times each, so we'd say there's no mode within that set. In the frequency table, we really just have to look which of this test scores had the biggest frequency. So it's actually even a little easier to determine if you know what you're looking for off of a table. All right. What do we mean by normally distributed? Well, if it truly is a normal distribution, we have perfect symmetry around the mean. The median is going to be right in the middle with the mean, so those are equal. And as you can see, the highest part of this graph right here is that same middle number, so that means it's occurring the most. And so the mode is equal to the mean and the median. They're all equal to each other, all right? That's when you have a perfect normal distribution. Most major exams like SATs, ACTs, AP exams are going to be scaled into a perfect normal distribution. They'll take the scores and they'll fit them so that they fit this model. That gives them a good idea of what percentage of scores are going to fall within certain ranges and such. Let's take a look at an example here. If a group of data consists of 6, 6.5, 8.5, 6, and 8, which of the following is true? And it just wants to know if we have some equality or inequalities of these values. Now, you could certainly just calculate these and then figure out which one makes the right answer, but you could, if you ordered these, which we could do fairly quickly, looks like 6, 6, 6.5, 8, and 8.5. We could probably figure this out without even doing some heavy calculations. It looks like 6 is the mode. Okay, it's also the smallest number. So that tells me that the median, the middle number, which looks like it's 6.5, is definitely not going to be equal to the mode. So the median is not equal to the mode. Okay, and the median is 6.5, the mode is 6. So as you can see, just simply by looking at the nature of these numbers, you can get rid of a couple of these. Now, we already said that the median is 6.5. We have not determined the mean, but I know that the mean of these 3 numbers is going to be between 6 and 6.5. You know, probably in the vicinity of 6.2-ish. And those 8 and 8.5 numbers are going to pull that much higher. It's going to pull it above 6.5. So I can probably figure out that the median is going to have to be less than the mean. So like if this was on a non-calculated test or you didn't feel like you had time to do the calculations, you could actually work this out. But if we did work it out, we would find that the average, the mean, was 7. And then as we said, the median was 6.5 and the mode was 6. And sure enough, the only one of these that is actually true is A. Okay, so don't hesitate to do the calculations if you need to, but sometimes you can save yourself some time. Here's a frequency table. Like we said, you're going to have to read these and understand what they're telling you. There's 3 scores between a 91 and 100, 11 scores between an 81 and a 90, etc. And so we just want to make sure we understand what they're asking for and interpret these correctly. The table shows 30 students, so that tells us we don't even have to count the frequencies. We know that's going to add up to 30 on a given test. In which interval does the median fall? Now, normally we'd have to put these 30 scores in order, but we don't even know specifically what those 30 scores are. But here's what we can do. we can say, well, halfway between 30 is going to be, what, 15 and 16? So we're going to have to average the 15th and 16th score. Well, 14 of those scores are above an 81 or above. And so if I start going up 14 on the other side, there's 8. Well, that means that I would have to, what, get another 6 of these, right? And that means there'd only be 2 of these left for the middle. And that means that if I average, I don't know what those 2 scores are, but if I average them, that's going to give me the median. So that tells me that we're going to have to fall, the median will have to fall somewhere between 71 and 80. Most likely because those are the 2 higher scores from that range, probably closer to 80, but we don't know that for sure. We just know that it would have to be between 71 and 80. And you can read over that written explanation, but that's pretty much what we just talked through. So that's how you would do this problem. Number 3, example 3. An integer data has 5 data points such that the mean and mode are equal to the median. So that means that this would be a normally distributed set of data. If 4 of the 5 points are 9, 12, 12, and 16, what is the 5th data point? Now remember, they'll have to be equal in the end. And so far, we've got a mode, which is 12. And if I lined up what I have so far, and they are in order, 9, 12, 12, 16, you know, the middle number here is going to be 12. So that means that the median, no matter what number you pick, is going to have to be 12. Because if I pick a bigger number, larger than 12, this 12 would become the middle. And if I pick a smaller number, less than 12, this 12 would become the middle. So either way, the median is going to be 12. So these can't change, which means the only thing that's left is to make sure that the mean is also 12. That has to happen. And so once you kind of reason through that, you just set up a fairly simple equation. We're going to add the 4 scores we know, or the 4 values we know. We're going to add a 5th value to that, which we don't know, so that will be our variable. We're going to divide by 5 data points now, right? And we want it to be equal, the mean to be equal to 12. So this is how we want it to work out. Easiest thing to do here would probably be multiply by 5. We could go ahead and add the 9, 12, 12, and 16, and then subtract 49, bam. That missing data point has to be 11. So just a little logic and a little algebra, and there's our answer. You'll see a lot of these types of questions in the packet, and these are fairly common questions within the PSATs also. Here's another similar type of question. Gail has taken 6 tests and has an average of 78. What does Gail have to score if she wants to get her average score up to an 80? Well, there's different ways you could tackle this. One way, certainly, you could say, all right, well, so far she's got a total of 6 times 78 total points. This is what she has so far. And then you could say, I want her total after 7 tests to be 7 times 80. This is what we want the new total to be. And so whatever the difference is between these 2 totals would have to be that new score. That's kind of one way you could attack this. But this is another great opportunity to set up another one of these equations where if I take this total, 6 times 78, and add it to a missing score, and then divide by not 6 tests, but that's a total of 7, and set the average equal to 80, the algebra will basically do this calculation for me. So there it is, 6 times 78 plus the unknown 7th score divided by 7. Let's multiply both sides by 7 to get rid of the denominator. Let's also multiply 6 times 78, and then a simple subtraction will give us a score of 92. So apparently Gail's going to have to do a little bit better than she has been doing to get her average up to an 80. All right, so those are mostly questions that dealt with center. Now let's start talking about the spread a little bit. The range and standard deviation are the two primary types of spread, as I mentioned, and the range is the simple one. It's just the difference between the highest data point and the lowest. And so you can see in this little example, 5 is the lowest, 30 is the highest, the range was 25. More likely, we're going to be talking about standard deviation. It's a measure of the spread or variation in terms of each number's deviation from the mean. So this is a lot of verbiage for you to take in if you haven't dealt with stats very much. When you start dealing with these problems, you get used to it fairly quickly. But this is the kind of stuff you'll be doing a lot if you take stats, AP stats, somewhere down the road. You can see that when you do have a standard deviation, you have a really lovely, and I think we have a bigger picture on the next page. Why don't we go there? A really lovely feature that happens, okay? If it's a normal distribution within one standard deviation, and this little sigma is, so this guy right here is a lowercase sigma, and that is the symbol for standard deviation, for one of them. And what it's telling us is if we go one standard deviation above or below the mean, remember x bar is the mean, then I have roughly 68.2% of all of the data points within that. 34.1 below, 34.1 above. And if I go two standard deviations out, now I'm almost all of it, 95.4%, only about 5% left. And so you can see with normal distributions, the general population of data points is clustered very close to that center. All right. What do we use standard deviation for? We use it for measuring spread and sample populations. Large standard deviations will tell us if there's a lot of variability within the data. That means a lot of lows and a lot of highs. On the other hand, if it's a small standard deviation, that means it's a very clustered set. So like if I gave a quiz and the highest score was 46 and the lowest score was a 38, so all of you guys are either a mid-C or a low A. That's a very tight cluster, you know, not really a lot of super high scores, but there are no low scores at all. That would mean that it had a small standard deviation. Sometimes your quizzes have higher standard deviations, sometimes they have lower. Standard deviation is the average amount by which the values differ from the mean. Now this is, I think, the easiest definition to understand right here, okay? And so this is not a perfect calculation of standard deviation, but I think it'll help you kind of understand what it is, because you don't want to have to calculate it using this formula. Nobody would want to do that by hand. Even the people that used to be statisticians before calculators and computers didn't really want to do those calculations. Luckily, we have calculators now that do it for us. But here's my example. I just made up 5 quick numbers. I found the mean, and then on a number line, I showed you where that mean was. It was right here at 7.6. So that's right here. I then plotted the other 5 points, the original 5 data points, along the number line. Okay, no big deal so far. So what we want when we talk about what standard deviation is we want to kind of figure out how far away from the mean these 5 data points are. And so I found that one of them was 3.6 units, one was 2.6, one was only 0.4. This one, 9, was 1.4 units away, and 12 was 4.4 units away. So then I just took those 5 differences and I averaged them. Now, that's kind of an idea of what standard deviation is. It's not perfect, but it's a general idea. As you saw, what we do is not only do we add those, but we square them before we add them, and then we take the square root. And so you never end up with the exact averages. It kind of always throws it a little bit off, but it's pretty close. So my average distance from the mean was 2.48. I let the calculator, because I didn't feel like using that formula, I let the calculator, you guys can do these on your calculator. will show you how if we have time this semester, but I just put the 5 data points in here and I said run one variable statistics for me, and there's that 7.6 mean that we talked about, right? Same thing I calculated above, but here's that standard deviation it came up with, and you can see that mine was 2.48 and it was coming up with a 2.87. So a little bit off because this isn't, we didn't, when I did mine, I didn't use the square roots and all that, but that's basically what standard deviation means. It's just what's the average distance of your data points from the data point that we assume is the middle, okay? You're not going to need to calculate it or anything like I said, but we are going to want to answer questions on sets of data that are in this bell-shaped curve, right? This normal distribution is what we call it. And it comes back to how many standard deviations are we away. It's called the empirical rule. The empirical rule for a normal distribution is what you'll call it in your statistics classes if you take those. And it's also, most students call it the 68, 95, 99 rule, because within one standard deviation, we talked about this earlier, you're going to find 68 roughly % of the data. Within 2 standard deviations, that jumps up to 95, and within 3, it's actually bigger than 99. It's closer to 100. It's like 99.7. But within 3 standard deviations, you almost have every single number, and if it's not, it's a big time outlier. There's formulas that will tell you how far out outliers are. Usually it's about a standard deviation and a half before it's considered an outlier, but that's probably beyond what we need to talk about right now. Here's a couple examples that are normal based things. This is a normal curve for IQ tests. They don't really give these much anymore, but they used to, boy, back in the like 50s and 60s, every elementary student would have an IQ test, and you can see that nice normal curve it fits. And the usually they were scaled at 100 for the mean, with a standard deviation of 15. So that means that within, let's see here, plus 15 and minus 15. So 100 plus 15 would be what, 115? And 100 minus 15 would be 85. So between 85 and 115, 68% or over 2/3 of the entire population had an IQ within that range. So that was highly considered normal IQs, and like if somebody had a 92 and somebody had a 105, I mean, there's not a huge difference between those values is what this is telling us. They're both kind of considered a normal range. Now, if you go out another standard deviation, so now we're what, 100 plus 30 is 130. Is that what we're up to now? And 100 minus 30 is 70. So now we have 95% of the entire population. So most, like almost the entire population, except for 5%, would have an IQ between 70 and 130. So that's how they use standard deviations. Now, something that'll probably be more specific to how maybe you measure it, right? Or to how you would want to use standard deviation to measure would be like when you take the SAT in a year or two, because they have a normal distribution for this test as well. They like to call the mean 500. They scale it so that that happens. And so what that means, right, is that, oh, by the way, the standard deviation is 100. So that means that 68% of all students on, say, the math, which is an 800-point test, are going to score between 400 and 600. And that's a big chunk of people. If you want 95% of all test takers, so that's almost everybody, you go another standard deviation out, and between 300 and 700 would be 95% of all test scores. So you can start to really tell when those scores are getting high. If you're getting above a 700 on any of the SAT, either English or math, trust me, you're in very small, distinct population of people. But anyway, let's look at some examples like you might see in the homework packet and then on the PSAT. On a standardized test, the distribution of scores is normal with a mean of 75 and a standard deviation of 5.8. Suppose Lorena earned a score of 82 on a test. Her score ranks where? Lower than 1 standard deviation, exactly 1 standard deviation above the mean, higher than 1 standard deviation, but lower than 2, higher than 2 standard deviations. Well, remember, the mean is 75 and the standard deviation is 5.8. So this really just becomes an addition problem. Let's go ahead and write these specific values in here, I guess. So 75 is the average on this test, and 5.8 was the standard deviation. So I'm going to add 5.8. So that's going to become 80.8. 80.8 is 1 standard deviation. Now remember, her average was an 82, so she's definitely above that. If I added another 5.8, if I added another standard deviation, 2 standard deviations out would be 86.6, I believe. 86.6. So she was below that. So I think she's in this this area. So pretty well. I mean, pretty good job. But between 1 and 2 standard deviations is where we would say that she is going to fall. And so it looks like based on the answers, I think C was the one that said more than 1 but less than 2. And sure enough, that's what we got. Answer C. All right, example 6. An amateur golfer calculated his scores for 5 months, okay? And if his data is normally distributed, how many of his 60 games were within 1 standard deviation of the mean? So I think this is where we just have to know that 68, 95, 99 rule. Within 1 standard deviation is 68% of the data. So I think if we multiply 0.68, or if you really want to be accurate, 0.682, I think 0.68 would be fine. 0.68 times 60, right? 0.68 times 60, we'll get an approximation. So 40.92 is right around 41 games. So about 41 of his games would be within 1 standard deviation of his average score. All right, so that's how we use standard deviation. Hopefully these examples and explanations were helpful. Please feel free to email me if they weren't. In fact, I think on Google Classroom, I will be available for you, let's say 2 o'clock today, from 2 to 2:30. Why don't you pop on and chat, and if you have any questions or if you start working through the packet and have any questions, I'll try to answer them for you. But this is the packet we're doing tonight, the data packet with the means and the standard deviations and medians. Hope you all are doing well, that your families are doing okay, and yeah, hang tight. We'll talk to you tomorrow.